so forth. Using, for the first electrolysis involving dilute or concentrated CuSO4, platinum electrode is used. But in this case now, we want to change the electrode use. Instead of using the platinum or graphite, we use copper electrode. Pure copper at the anode, pure copper at the cathode, and impure copper at the anode. So what happened? The nature of the electrode will now affect discharge at the anode. That is the problem of this particular electrolysis. Because we are changing the electrode use. The common electrode that are being used in electrolysis are the platinum and the graphite. They are inert and does not affect reaction. So when you change them and you use metal, the reaction at the anode will be affected. Nature of the electrode comes in. So for this electrolysis now, we using copper electrode. The electrolytic cell for the electrolysis of dilute or concentrated CuSO4 using copper electrode. For this electrolysis using copper electrode, the nature of electrode affects the reaction at the anode. What happened at the anode? At the anode, the SO4 2- and the OH- in solution migrate to the anode. Instead of the OH being discharged, which is supposed to be OH being discharged, there is no discharge at the anode because of the nature of the electrode use. What happened? Instead of either of these two ions being discharged, the anode takes part in the reaction. The anode dissolves away in solution as copper ion, which now goes into solution to replace the copper ion that is being removed at the cathode. So let's look at this now. Let's look at the half reaction. Let's look at the half reaction for this electrolysis. We have anode, we have cathode. SO4 2-, OH-, Cu2+, H+. This is discharge. None is discharge. No discharge. No discharge. In this electrolysis, SO4 2- and OH- migrate to the anode, Cu2+ and H+ migrate to the cathode. At the cathode, Cu2+ is discharged. At the anode, none of the two ions is discharged. Instead, the anode takes part in the reaction. So let's see the half reaction now. Half reaction at cathode. Cu2+ plus 2E equal to half reaction at anode. I said at the anode, OH- is not discharged. Instead, the anode dissolves in solution as copper 2 ion. So the half reaction will now be copper solid now. The impure copper anode losing electron. Losing electron to give us Cu2+. But I said we don't write minus. In modern chemistry, you go here and you. So this is the half reaction at the anode. The copper anode dissolving in solution as Cu2+ by gaining 2 electrons. So what happened in this electrolysis using copper? What happened in this electrolysis using copper electrode? It's just a mere transfer of copper from the impure anode to the pure cathode. There is no reaction, nothing happens. At the end of the day, the impure anode is transferred from the impure anode to the pure cathode. So it is used in purification of copper element. So let's look at what happened in the electrolysis of the solution. What happened? Let's look at the effect of electrolysis on the electrolyte solution. I said that this electrolysis is used in purification of copper. It is just a mere transfer of copper from the impure anode to the pure cathode. Simple. No product is discharged. No product is formed at the end of the reaction. Now let's look at what happened at the end of the reaction. At the end of the reaction, what happened to the color of the cell? We have this. None of this is discharged. This is discharged. This one that is discharged. Okay, what happened to the solution at the end of the reaction is that the color of the solution does not change. At the end of the electrolysis, the color of the solution does not change. Why? Because the copper ion, which is taken away from solution and deposited at the cathode, is being replaced by another copper ion that dissolves away from the anode and goes into solution. And therefore, the color of the solution remains unchanged. Is it clear? So, effect of electrolysis on the electrolyte solution. The blue color of the solution does not change because the copper ion in solution, which is removed and deposited at the cathode, is being replaced by another copper ion that dissolves away from the anode and goes into solution.